In this video we want to learn how we can find the greatest and least values in a given inequality. So let's look at this example. We're given the set of values of x from -3¼ to 2, where x is an integer, and we want to find on A the greatest value of those terms in x, and on B the least value of those terms in x. Okay, so let's go on to the solution. The first thing here for us is to write down the values that are in the set. These are integer values. If you look at the set right here, x is an integer, and the values of x range from -3¼ to 2. Okay, so what we do here is you can just list down the integer values within this range from -3¼ to 2. You may use a number line if you want to, but it's quite easy just writing down those integer values, and these are -3, -2, -1, 0, and 1. So these are our integer values within the range. These are values of x that are integer values. Now we want to find the greatest and least values, but within this set you can see that -3 is the minimum value and 1 is our maximum value. That is the greatest value right there. So that if we go on to part A part 1, in order for us to get the greatest value of 2x, what that means is that we'll be multiplying the values of x that we have by 2. All these are values of x, and we want to see which one will give us the greatest value. Now you may not necessarily need to multiply each of the terms by 2, but just using a little bit of reasoning, you can see that in order for us to get the greatest value of 2x, we get that value when we multiply 2 by the greatest value of x, which in this case is 1, so that we get the greatest value of 2x. So that's 2 of 1, and the greatest value will come out as 2. So that's the solution. That is the greatest value of 2x. Let's move on to part number 2. We want to find the greatest value of x squared. Now for x squared, the greatest value of x squared, we simply will be squaring our terms in x. But you see, we said you do not have to square all the terms, but looking at our values that we have, we also have negative numbers here. You need to know that when we square negative numbers, the result comes out a positive number. So that means that the greatest value of x is not necessarily going to come out when we square the greatest value 1, because even if we square the least value -3, we get a greater value than the square of 1, right? So in this case, actually the greatest value of x squared comes out when we square -3, which is in this case our least value. So -3 squared gives us 9, and the greatest value of x squared is 9, right? So it's also important when you look at the greatest value of a square to consider that squaring a negative number gives you a positive result. So a least value, which is a negative value, can become the greatest value when squared. Let's move on to part number 3, where we want to find the greatest value of 1 minus x. Now that's a difference. Now the greatest value of the difference from 1 minus x will come out when we subtract 1 minus the least value, the minimum value of x. That's where we're going to get the greatest difference from 1, when we subtract 1 minus the minimum value, and our minimum value in this case is -3, and this will become 1 plus 3, and that will be equal to 4. So that is the greatest difference from 1 when we subtract 1 minus the least value, which is -3. So that will be our least value. Alright, let's move on to part B. On part B, we want to find the least value of on part 1 we want the least value of x plus 2. Now in order for us to get the least value of x plus 2, then we have to use the least value of x and add it to 2 so that we get the least value of x plus 2. And the least value of x is -3. Alright, so that's -3 plus 2. That will give us the least value, which is in our case -1. So that is our least value of x plus 2. That's the solution to B part 1. And for B part 2, we want the least value of 1 over x squared. The least value of 1 over x squared. Now when we have this situation where we've got a constant over x squared, where x is any value, in this case any value within our set of integer values, you need to know that when we divide that constant by, so k represents a constant like 1, by the greatest value, then what we're gonna get is the least value. But if we divide a constant like 1 by the minimum value, then what we're gonna get will be the greatest value. So we get the greatest value when we divide a constant by the minimum value, and we get the least value when we divide a constant by the maximum value. So this is very important, very, very important. So in our case, we want to find the least value of 1 over x squared. So that means that we're gonna need, in order for us to get the least value, we're gonna need the maximum value of x squared in order for us to get the least value of 1 over x squared. And the greatest value of x squared, in this case, we obtained it in A part 2. It came out as -3 squared, which was 9. So we'll be saying that's equal to 1 over -3 squared, which is 1 over 9. And 1 over 9 becomes the least value of 1 over x squared. Now I want you to recall this. This is very, very important. This point is very, very important. Dividing a constant by a maximum value, you get the least value. But if you divide a constant by the minimum value, you get the greatest value. So that is our solution. That is how we find the greatest and least values. I'll be giving you more problems to work out so that you may understand better how we were doing this. I want you to play back this video and try to make sure that you've grasped how we find greatest and least values in the situations that we had.